is Elizabeth Graham from Wilson Tool. I want to welcome you to the latest webcast in our free webinar series, Distortion in the Punch Press, Understanding the Causes and Identifying Solutions. Thank you for joining us today. In our webinars, we aim to demonstrate helpful tips to common sheet metal manufacturing challenges in a convenient online format. We are recording today's presentation, so if you want a copy, you'll be able to access one from our website in just a few days. Also, just so you know, no information about attendees is displayed to other participants today or on any recorded material for privacy reasons. If you experience any technical difficulties during the webinar, you can call WebEx technical support at 1-866-229-3239. Also, please be aware that you will be in a listen-only mode throughout the presentation. However, you can submit questions for Scott anytime throughout the presentation. Just type into the Q&A box to the right of your screen and hit send. The box is labeled Q&A and is identified by a question mark icon. Make sure to select all panelists in the Send To list so that your question goes to the right place. You'll also notice a chat box that is identified by a word bubble. Please only use this feature if you have a comment or need immediate assistance from one of the hosts. Please do not use this feature for questions about the presentation. There will be several poll questions asked during the presentation. To answer these questions, you'll notice a poll box pop up to the right of your screen. Click on your answer and hit submit. Your individual answer will not be made public to other participants. I would like to also introduce Vanessa Greer, who will be co-hosting with me today. We will be organizing your questions as they come in and running the polls behind the scenes. Finally, I'm pleased to introduce today's presenter, Scott Tashney, an application specialist at Wilson Tool with 27 years of experience in the precision metal fabrication industry. With that, I will now pass the presentation over to Scott.
Thank you, Elizabeth. So it's taken. Before I get into the causes for sheet distortion and the solutions, let's make sure we're all on the same page regarding what is sheet distortion. That would be that unequal growth or reduction between the top and bottom of the sheet, which results in a cupping or bowing, sometimes wrinkling, and in the worst condition, tearing. Managing the distortion, we're going to take 4 approaches. We're going to discuss clearances, programming. We're going to talk about the form itself, tools and machine options, and then some really unique special tooling features. Before I get too far, I'd like to point out that many of the images are exaggerated for visual effect. I would also like to point out that I view the webinar as a first step in sharing this information. Managing sheet distortion is probably the most difficult thing we can do in a punch press. So although I will share a lot with you, I'm not going to be able to get too deep in it, but there'll be enough to spike good conversation between you and I, either through the Q&A or you can contact us at a later date. Sheet distortion, there you go. We get those sheets cupping and those wrinkles. Makes our life a living nightmare. But when we're chasing the solution, we're going to make a change, right? We were looking for a positive change, but along with a positive change, something else is going to happen. Sometimes it's a negative occurrence. I might increase sheet marking while I'm decreasing sheet distortion. On the slide, you'll see little icons in the upper right-hand corner. I'm trying to identify what I believe is who can affect this. You know, C is a customer requirement. They're going to give you a drawing. It has dimensions. It is an object. If you can identify that it may cause you problems, that's something you should discuss with your customer as soon as you can. Sometimes we're buying tooling just for prototyping, or our budget isn't as strong as we'd like, so we buy different tool designs. We call it economy tooling. That might come into play. So to resolve the distortion, we might actually have to spend more money. Machine abilities. Machines are coming with a lot of neat abilities today, and we don't always use those abilities because the tooling might cost more. but those features are being put into the machine for very good reason. And then along the way, I'll kind of point out a little DIY that, tricks you can do to your tooling on the fly to help decrease that distortion. So what causes it? Virtually everything we do in that sheet. When we're piercing a hole, the most common is a little inward draw. If your clearance is small, it can do an outward push. We'll show that clearer later. A lot of embosses, that's one of the most popular forming tools in an up direction. That's going to draw in. It's going to give a bow. And then we have coining. When we compress that material, it literally wants to squirt out, so it's going to grow on the top side and it's going to cause some distortion. So first we'll start with the clearances. And I know a lot of people use standard clearances, sometimes just to make it simple. So guys don't have to change out die clearances all the time. And you've proven that for the most part, one clearance works in everything. Great. I know some customers are standard up to 3 different die clearances. They're good practices, it's good information, but sometimes we have to ignore the norm to decrease our distortion. So Wilson Tool and every other tooling manufacturer publishes some sort of die clearance selection chart. We talk about what's kind of the best area, what's that window, but they're guidelines. So if you're fighting distortion and you're doing mainly piercing, you should look at your clearances. Kind of give you the visual support. Our clearance, our die is bigger than our punch, so we have that natural rotation inward. Generally, it's going to pull, create a cupping action. So the larger the clearance, the more rotation you can expect, the more inward draw. So we're going to get a cup distortion. But if you start micromanaging and you get to a smaller clearance, you can go too far and you can create a bow, so a different distortion. Or here you can cause galling on your punch. So as we make those change, be aware. At some point it's going to go in the opposite direction and cause other problems. When we have that too little clearance, we also get this little bulge on top, so it can grow in the other direction. This is probably the least common problem with piercing, but when customers find that they need to go to a smaller clearance so they have an acceptable burr, because with these hybrid materials, we really have to play around with clearances to get the right effect on the bottom of the sheet, or possibly a blank if we're doing blanking. We need to minimize that burr, so sometimes we're getting into a clearance range that's outside the norm, and unfortunately you can cause some sort of distortion that way. So with too small of a clearance, you're going to get that outward push, giving you that distortion. So if you're playing in standardized clearances, that might be a simple game changer right there. Just work with some different die clearances and see how things change. I put a DIY on that slide because a lot of people do have different clearances, so swap it out on the fly. So at this point, I'd like to take a small poll, 2-part question. Have you previously recognized die clearances as a contributing factor to distortion? And then if you have you played and tried different clearances in an attempt to reduce that distortion? So if you could use the poll question box in the lower right-hand corner of your screen, that would be appreciated. Just to give you an idea, it looks like we have about 60 attendees so far today. People still showing up. Do we have some, okay, that I see the numbers are coming in. We got about, is it about 100%, almost 100%, 60, 80? Mm-hmm. So just the feedback, it looks like 68%, about 68% of the people have recognized die clearance as a contributing factor and have played with it. But surprisingly, 23% have never recognized die clearance as a possible problem. So we have a good mixture of people. This is good. And one of the things I'd like to point out is the material that I'm sharing has been built from years of experience, realistically hearing from customers what they're doing to get through the problems. I have the luxury of doing a little bit of testing here, but it's only testing. I really don't live in that real world of fabrication, so I don't get to live your little nightmare. So this is an experience from a lot of different people. And one of them, next topic, is programming. You know, I kind of put automated programming is not your friend. I know people are chasing automation, right? It's all how much can I get through my machine at one time, or how fast can I get it done? But sometimes the result is greater sheet distortion because the program has taken a logical, mathematical approach to it, and that can not take into account for sheet distortion. There really is no genius behind that. I'm just kind of clicking through how somebody might have to arbitrarily program this perforated sheet to minimize its distortion. Doing that really takes a talented programmer. I know it can be done because I've seen it done. Now, admittedly, I've only met one person who did this very well, and I would describe it as more of an art than a science. You know, it's kind of an intuitive aspect of programming. So it's something people can do, and it slows down your production, so it does cost money. Managing distortion through secondary hits. Hole shaving, hitting the hole twice. You'll see two circles on your screen. The one on the left is representing, you know, a standard die clearance, how you might get your rollover and your breakaway. The process of punching material is reducing stress in the sheet, but it also initiates stress around that aperture where you cut. So if you can remove some of that stress with a second cut, shaving it away, you can minimize or reduce some of your distortion. Now, some might argue, well, just because my tool hit the sheet twice is why it works. Well, there's some truth to that, but the reality is a company that many of you probably use their machines, Trump, has done a substantial amount of testing. And they publish this in their user manual. So for those who happen to have access to user manuals for the machines, I strongly suggest you look at them, read them, because there's a lot of information directing you how to reduce your distortion. And they published that they had a 50% reduction in sheet distortion when they first punched with the 9.8 millimeter punch followed by a 10 millimeter punch. Doubles the hits, but the reduction in sheet distortion pays for itself. Extrusions. Customers do a lot of extrusions, and when they do it, it's almost like that perforated sheet. They do lots of them for coil feeds and a variety of things. Customer told me that his solution for dealing with this distortion so he didn't have to do a secondary process was he would just grab an empty assembly, you know, a guide assembly, take out the punch, and use the aperture of the guide or the stripper to straddle the extrusion and just go tamping the sheet. More hits, it's going to cost some money, but it works. So programming, you know, multiple hits, that can help you. Don't try to get the part out of the machine too fast. And then if you can work at randomizing your program, that'd be phenomenal, because the automated programs not only ignore what can happen with sheet distortion, it doesn't do anything for your tool life either. Now we're going to talk about some forms, the tools, and then the machine designs. This image on the left is a bridge lancing form. So the die is lancing the material, cutting the material, and creating the form. Where the form on the right, it's just a form only. So somebody pre-punched around the edges and then they're just lifting it up. Now, the form on the right has a more likelihood to distort because the material can only stretch so far, and it's going to want to drag it inward. It's just a natural aspect of that forming operation. It wants to pull it in. We saw that earlier on when we did the emboss. It wants to draw it in. But when I'm doing a bridge, if I have that lancing feature on the tool, the lancing allows it to stretch the whole process while it's making that. It stretches, it's like micro tearing. So it's stretching the material along the leg of the bridge much better than what it can naturally do on its own in a form-only bridge. So you're not going to have the distortion that you would in a form-only bridge. That's all the case. So I have that dollar up there because a lot of people are thinking, I can save money by doing a form-only bridge. But then they start fighting the form might tear, it distorted so much it tore, or they have an exorbitant amount of sheet distortion that only can be resolved by turning it back to a lance and form bridge. So be careful about the tool you're ordering. So here's the C in the upper right-hand corner. So I know, get requests from your customers. They're going to send you a 3D model, maybe it's a blueprint drawing, and it's already detailed for you. What I'd like to do is make sure you understand the features on that form and how it comes into play for sheet distortion. The outer radius at the sheet is your opportunity to hold the sheet flat. So the smaller that radius is, the less inward draw this form would have. The inner radius, if we can maximize that, make it bigger, it's going to ensure that the distortion is happening at the top of that emboss, around the edges, and not pulling in from the sheet. And then a pre-punched hole can also help draw it in from the top of the sheet. In this case, it's kind of probably only about a third, maybe 25% of that emboss. It actually isn't going to help much. If it were larger, it would help. But these are things that if you can understand the form that you're looking at, if a customer shows you a large radius on the outer edge, you can expect some sheet distortion. Ask them if it's okay to minimize that. If you could ignore their model or their drawing and say, hey, I want to make my radius smaller on the outside and larger on the inside, that'll help. This is information that you can share with your customer to kind of head off your problems. Sometimes they won't let you make the change. So when we have a problem where we expect distortion, and when we see it here at Wilson Tool, we'll probably quote on the front side a preforming operation. So one of the most common preforms would be a dimple in front of an emboss. And by the shape, you can see I have the ability to put a small radius at the sheet, minimizing that inward draw, and then I have this large shape, spherical shape. It's going to help perpetuate or create that thinning. So we're going to thin there, and we're not going to have that sucking in motion. On the tool side, pad pressure, that's the force that's holding the sheet still. It's innate to a guide assembly. Here, when I have a guide assembly, I have spring pressure behind it, so I get to hold that sheet flat. One of the things people don't like about it is it'll create a witness mark. So they're often looking to reduce that force, that spring pressure, to reduce sheet marking. So, it's which one do I want, sheet distortion or sheet marking? It's usually a trade-off. To better explain it, on the left you'll see a guide assembly, spring on top. That's where the force is coming from. And on a forming tool, we have springs in the lower unit. And you can kind of understand from the picture that there's only so much force we can put in there. There's only so much force we can have. But what we do get into that spring-loaded die assembly does help. And the proof is customers who do buy the economy style tooling often call back when they're going into production and say, okay, I have sheet distortion problems. What do I do about it? And it's as simple as, well, let's get you into a spring-loaded die assembly. Regarding spring-loaded die assemblies, there's often an opportunity to put heavier springs in them, or often a tool might leave the plant where they reduced the number of springs in the die assembly because there was sheet marking. They thought it might have been best. So you might actually have an opportunity just to grab some springs off your shelf, put them in there, and help resolve. Here's another image that I like to use to talk about pad pressure. This is a slitting tool. The thing about the slitting tool is we relieve the die and we relieve the stripper so it can get close to clamps. Very common. By doing that, we took the amount of force that we had behind the stripper plate, which is pretty large in surface area. We reduced that surface area so we were able to concentrate the pressure. It does increase sheet marking, but it really cuts down on the sheet distortion. So I put on here, it's a DIY. If you're experiencing sheet distortion with a piercing tool and you have the ability to grind some material off the stripper plate similar to what you're seeing in front of you, and possibly even the die, you can concentrate the force and that will help you decrease sheet distortion. Now from a machine feature, this is the ultimate in dealing with sheet distortion. The next slide is the best picture of it. It's called the P&F system. This one is offered by Amada, where the sheet stays flat. My punch, in this case it's an extrusion. My punch upstairs comes down and it can utilize all the force, all the pressure of the machine to hold that sheet flat. So if I have a 30-ton punch press, it can use 30 tons to hold that sheet flat. You can imagine if you went overboard, it would squirt out and not work so well. But with that ability of holding the sheet flat, now I activate my lower ram, I can create all those extrusions. If I was doing a tubing assembly, lots and lots of extrusions, and it's virtually a flat sheet. Customers buy this, or sometimes it came free with the machine as an option, but they never started using it because it does take specialized tooling. But when you're fighting that sheet distortion, sometimes the up price for the tooling is the right solution. And the customers that I have that use this option the most are doing something as simple as electrical knockouts, and then the other one would be a lot of extrusions for tubes. So if you have those machine features, it's very important that you take advantage of them. You paid for them, use them. So kind of a quick little test. Which forms are likely to distort the sheet by allowing it to pull inward? A, B, C, D, both A and C, or both B and D. This is, hopefully it's going to be an easier one. Tell me how well I'm speaking and how well everyone's understanding it. If you get it wrong, I think you should call me later on. Okay, we got a lot of people coming in, and yes, B and D. People are recognizing that, 83%. There's very, very low number of people who are suggesting it's B or C or D alone. The correct answer is B and D, and that is a very, very large portion of you answering. So things are going well. Tool features. This is kind of where things will kind of get really weird for some of you. Perforation, that's, perforating a sheet is one of the most common places for sheet distortion, so people are using cluster tools. The most common solution, or attempt at resolving sheet distortion is staggering your inserts. Rather than having, all the inserts squirting it out, we get to take only some of them, drawing in or squirting out depending on your clearance. And then the second stage of inserts, it's really mitigated. It's really almost negligible what happens to the sheet after that. This is the most common solution people are using. The nicety about this is often they're using inserts. They're going to go sharpen a set of inserts, and then they only put half of those inserts back in the cluster, put brand new ones in there, and they're creating that stagger all by themselves. If you were to call up and say, hey, I want staggered inserts, there is enough charge, so it's very small, but it costs you. But the DIY part is you certainly can do that on your own if you do sharpening. Backbending, or a weakened stripper to help promote backbending. Here's a case where we used a smaller die. We adapted it to a large system. So there was this natural pivot on the corner on the die because it's raised up higher. And if we create a weaker stripper, we can create some bowing, because when you're piercing, it's usually a cup. So if I can push it in the opposite direction before I pierce it, we're trying to negate it. Here's another example where a trunk tool, the stripper has kind of a natural weakness to it. It will flex if you put a little tip on your die. Nice little natural backbending. Now, there's two different ways we could do this. We could approach it and put a spherical shape on top of the die, a spherical shape in a stripper, and really positively bend it. But when we go down that road and you sharpen it, well, now you're changing the condition more drastically than this approach where we're using a flat top die. We're relieving the sidewalls, creating a pivot point. There you can sharpen it without really changing the outcome very much at all. All you have to deal with is, we have that bend point on the die. You want to make sure you get a nice soft radius on that when you're done sharpening it. But, hey, we're backbending, we're creating these pivot points. You can create sheet marking. Got to be careful with the size of your radiuses and how much pressure you're putting behind it. I always say it might not resolve your sheet distortion, but it will improve your sheet distortion, no matter how well effective it is. Here's that case where we were doing that bulge. I had a customer who had to use small die clearances to have a decent burr, an acceptable burr on his material when he was done. But what it was causing that bowing sensation. So what would be the strategy to keep a small die clearance, but yet create an inward draw of that sheet? We have a feature we call JK shear here at Wilson Tool. So by putting a slight chamfer around the outer edge of that cutting tool, we're going to ensure we draw inward versus pushing it out. And then it'll cut and help reduce some of that distortion. Here's a case where it was applied to a cluster tool, and the cluster insert was small enough that the amount of chamfer we applied virtually took the whole face of that punch. Works pretty nice. It's one of those extreme ones because it doesn't happen all the time because people's die clearances are generally in a condition where it creates cupping versus the bow. So here's a series of tools that shows, we have a backbending die. We do the flat top so you can sharpen it. We have those JK shear inserts on the cluster. And then we have a weakened stripper that we remove material on the inside of that stripper that's going to help it flex during the piercing process. Now these are images of the tools. You certainly wouldn't use all three of those at the same time because they're dealing with different types of distortion. But just an image to let you see what's going on. So adding a stinger. Here's another fun solution. It works well, but the reason it's not applied a lot is it's an additional tool and it makes a mark on the sheet. So here we get to see I added a stinger, which is like a chisel point, a little groove around where I want to make my form. And then my emboss tool has a feature to go inside that groove, lock the sheet from pulling in, and create our form. So we have that earlier feature, which costs us money. It's a second tool. Got to hit it twice. You know, I'm hitting it again. People don't like the fact that there's this look. And here you are. There's the look. I got a stinger. That's not always acceptable. Some customers, I don't know how, but they're putting enough powder coating on there to cover that channel up. But it's an effective solution. A similar one is where you might do a true emboss like a ring dimple, a flat-walled rib-style stinger around a very large emboss. And this is an actual screen capture of a tool that we did make for a customer who was hitting a relatively heavy gauge stainless steel. The form was just shy of 400 thou tall, and they had to minimize that distortion. So this was the solution, and it worked very well for them. Pointing out the stinger, it does cost, right? It's an upcharge, it's an extra set of tools, I got to hit more. Another feature would be something as simple as pinching the sidewall of that form, right? When we put side set, it's going to change the appearance of the material. I describe it as it's going to be shiny on the sides. It's pretty effective. It's often the solution. The first thing we do when a form distorted to the point where it tore, in essence, we go back, let's go smash it back together. So it's very effective. So if people can accept a shiny wall, looks pretty good. And this whole process works on wheel tools as well. I can pinch the sidewall of a wheel to help reduce that sheet distortion, right? On the left, straight up wheel. On the right, we pinched the sidewalls. Actually, we even made it shorter, smaller, and it worked very well. Kind of showing you some creative solutions. When we pinch those sidewalls and we run them concentrically, we can get some pretty tall forms. So that part was made with very little sheet distortion. We have solutions that can help in straight line applications as well. I'd like to do a little show off. So of these special tool features, I'm curious how many of you use them to help manage sheet distortion. So you should be able to check all of them that apply. So I'm curious who's doing staggered inserts, who might be doing backbending, who's accepted the pinch walls, you know, that shiny sidewall of forging, possibly use stingers. I'm really curious how many people have that Amada P&F station and actually use it. And then we certainly have the none of the above. I hope I don't see a lot of none of the above. Wow, my none of the above is growing pretty drastically. It's clicking. We got our people coming. Okay, well, I'd say about half of the people at this point are none of the above. But we have a substantial number of people that have staggered inserts, followed by, you know, the backbending die. So there must be a lot of people using clusters. Those are very popular in that. Side set, that's a smaller group. Again, because it's shiny, and I know a lot of customers don't like that look. So they're looking for other solutions. They probably did some preforming. I probably should have thrown that in. So in the end, you know, looks like a little over 55% of the people have room, you know, to grow, if you will, in reducing their sheet distortion through some of these features. So with that, I would like to open it up for Q&A. And I see I got a couple questions here. Are there specific materials that are more susceptible to distortion than others? Mild steel, galvanized, stainless, so-and-so. I would say the harder materials are more susceptible to distortion, and the thicker material. I'm always amazed that when somebody has material that's, say, 20 thou thick, how far it will stretch and move without distorting or even tearing. Say I could go 6 times material offset on an emboss in a thin gauge, but if I went 6 times material offset in a heavier gauge, I would have tore it off, popped the top. The material just won't, it's not that elastic. So thickness and type. So the harder the tensile strength it is, more likely it is to tear or distort. With certain brands of punch presses that are better at controlling distortion than others. I pointed out the amount of P&F, and that's the only machine that has that particular feature that can hold the sheet with so much force. Now, aside from that, machine manufacturers are creating these objects they call forming stations. It might be a retractable die system, they'll call it. Those systems actually help manage distortion because they're really maintaining that, trying to keep the sheet at an even plane. So those work as well. So if you have a forming station and are not taking advantage of it, you really should. So machines that have that type of feature, which are most, I think, I guess now maybe at most in the extreme, it's probably 50% now that I think about it closer, have a forming station or retractable die system. Does work hardening play in the sheet distortion either helpful or detrimental? Yes. Work hardening is coming into play generally when I'm hitting it twice. Say I had to do a preform and then a form. I can be susceptible to work hardening. But in practice, I can't think of more than maybe a handful of times we couldn't work around that, where it worked hardened to a point where it failed. So I think, yes, from a possible standpoint, it's there, but it really doesn't come into play. When embossing a pre-punched hole, what is the most effective preform shape? Still spherical? Spherical is the most common, and it's the most, I guess it's the most common because it does work. When that doesn't work, then the next form is a ring dimple. For those who know what a ring dimple is, it's creating a circle. And the reason that works is I create a circle and then I'm pushing the middle upwards, so I'm unfolding my form. So ring dimples are effective. They're our second option, only because of history. What are the limitations on rolling forge tools we showed? What are the limitations? That's a hard one to explain because the rolling forge concept is growing and it exists because people need to do something in a turret or would like to do something in a turret that cannot be done in a turret today, and it's the only way it can be done. So I would mark the limitations as being, if you wanted a half-inch high rolled offset emboss, if you wanted that form that was half-inch high, but you wanted that 45-degree sidewall, I can't produce a 45-degree sidewall. The reality is we're going to do a pinch factor and we'll determine that I'll get you your half-inch height, but it might end up being a 30-degree or 37-degree. We can't control it that minutely, so it's more of a prototyping process. Some people are using it straight out of the box. A rolling forge gets a little stair step along the side wall. Probably could have added that little image. For those who are curious about rolling forges or any forge application, contact me. I can get you some photographs of what it really looks like. So the limitations are, I can't guarantee your form to dimension, really just to height. and then it's usually adequate from there. An Amada has a P&F. The trunk can hold the material with a stripper at 25 tons of force as well. What's the difference? Actually, that good point. The Amada stripper, 25 tons, is a piercing operation. The Amada P&F is dealing with the forming operations. So a good thing, thank you for pointing that out. The P&F, pierce, and form, it's really dealing with a forming tool. So in a trunk, I can hold, the question is how many forms am I creating, am I allowed to create in a trunk machine where I can take advantage of that stripper plate. Most forming tools don't use a stripper plate in the Amada. The controller might not even allow us to attempt to use it. But there are certainly cases where it can work. But for the most part, Trump is using the stripper plate for piercing, and the P&F is a forming machine. When using the side stitch strategy, at what point in the stroke does the material pinch versus gain height? I would say it really depends on the forming. When is it fracturing? So say I need to go 300 thou high on end form, but it's tearing at the 250, 200 height. That's when I start invoking pinching, somewhere around there or before there. So it's more of a what failed, identify where it failed, and then make sure we invoke pinching prior to that. So there's no real hard number. What I can tell you is a lot of the forms that we use the sidewall pinch, they're often an offset, a foot, or often a stiffening feature. And what I can tell you, stiffening features, people tend to do an offset in the material 4 times material thickness just because that's what they've always done. We've proven a number of times, and this proof is you, the customer, have taken a traditional form, maybe a rib, 4 times offset, and measured the result against a pinched wall rib that's only one material height, and which one's stiffening up the sheet more. Often that sidewall pinch tool will outperform the 9 sidewall pinch, and I can create the same amount of stiffenability. Is that a word? I think I'm making words up. In a much smaller form. So using that side stitch strategy, it really gets down to why am I using it? If it's due to tearing, if it's due to sucking in, and at what point that happens, that's when I'm going to start trying to pinch it a little bit sooner. The hole shaving scenario, is that assuming concentric hits, or is it a touching off at edge? Or is it touching off an edge? It is a concentric hit, yes, and I'm just shaving off the edge, so I'm not sure about the touching off. So yes, it's concentric, but I'm taking off very little material. Because when I punch a hole, the stress created by that shear, that hole, only goes into the material a small percentage of the material thickness. So my shave is pretty negligible. In a high-speed stamping system, they might actually create, because they can have so much stroke to a tool, they'll create the piercing tool and the shaving tool all on a single insert. Generally, we don't have that luxury in a punch press because we don't have that much travel. Can I share some specific examples where I've seen random programming hit location decrease distortion? This was a case where the customer was creating it was a part. So they had nested parts, but one of the parts had a variety of holes. just a perforation window, if you will. Similar to what I showed on screen, it was a whole bunch of holes near each other. And what they did is they arbitrarily did some randomizing to create less distortion. Because what was happening is it had a wave in it. You could push down or you could pop up. It was inconsistent as to what it was looking, that distortion was producing. But by doing it as a more random hit, it gave it a nice, even, slighter distortion. So I guess I can't, that's the best I can do on that description. So sorry about that. Staggered inserts. How is height difference determined? How much? Good question, because if you do it wrong and you have a trunk machine, you can cause lots of problems. Okay, you want, and I'm going to start with the trunk machine because this is kind of where it can really cause a nightmare. This trunk machine, when it pierces the hole, once it senses it's sheared, it's putting the brakes on it, wants to stop it. So if it senses it's sheared with my longer inserts and my shorter inserts haven't engaged the material yet, it's going to put the brakes on. You're only going to half your holes. So you're really doing it about a third of the material thickness is the stagger that seems to work well. You generally don't have that additional, stutter step, if you will, by a staggered insert that's going to cause a trunk machine a headache. So about a third of the material. Okay, well that's all the time we have today. If there are more questions, feel free to contact us at Wilson Tool. You can contact marketing at wilsontool.com, or you can reach out to me directly, scott.tashney@wilsontool.com, and we'd be happy to continue the discussion of dealing with distortion in a punch press. Thank you.
All right. Thank you so much, Scott. That was a great presentation, and thank you all for joining us and submitting those really nice questions. As Scott said, feel free to contact us if you have any further questions, and we'll be sending you an email in the next few days with a PDF of today's presentation along with a link to the recording of the webinar so you can download that or stream that online. You'll also be able to find the recording of this along with previous webinars that we've aired under the Media Center tab on our website. So we hope you found this helpful today, and we look forward to being a resource for you and your company in the future. Have a great day, everyone.